So this is what we have at the moment. This is the 30 kilowatt Frankenstein. Well, we're going to try and get as close to that as we can. So what I've decided to do is I've decided to use most of the lithium assembly for now. I'm not going to use the HCH2 DC to DC initially. I'm going to restrict myself to 190 volts maximum. That means I'll need like 155 amps current to get 30 kilowatts. But that's hopefully doable. So we've got the lithium IPU MPI, we've got the lithium DC to DC, we've got the lithium contactor set up there, and this fits nicely. Obviously we know this obviously fits all in the car. It's got the normal harness on, etc., and we know the ducting fits and works through underneath blowing, so I don't have to remake any of that, so that's made it quite quick to assemble that. So what I've done, this is where the main negative comes in here and the main positive comes here, so there's now an Anderson connector here, and this is basically where the battery pack will plug into. Simple as that. So my 200 volt 190 volt pack will just plug straight into that Anderson connector, and then we're live and ready to go. The only thing I have to put on my battery pack is the switchboard and fuse in the middle of the battery pack, so that we've got the safety disconnect. So what I've got to do here though is I've got to integrate the nickel metal hydride MCM, because normally we would have the lithium MCM sitting here, and obviously that's smaller, so the top won't fit on, but I'm not too worried about that at the moment. So basically I'm going to sit this here with the connectors at this end, which is the same as they are in the nickel metal hydride, and basically I then have to chop the connectors off my nickel metal hydride harness, and I have to put them onto the appropriate wires on the lithium harness, and these are pretty much identical to the lithium connections or lithium setup here. So I'm going to try the lithium phase sensors first, and I'm also going to try the lithium battery current module sensor, so we'll see if they work. I'm just going to check the voltages of those, but I'm hoping that they will actually work with the nickel hydride MCM, in which case it will just be a question of hacking these off and putting the nickel metal hydride ones on, or making some sort of adapter to do that. I probably won't bother with that, I'll just cut them off. Probably it's easier to splice them together there, and then that basically should just plug in and be ready to go. So that's where we are at the minute. So this is the electronics pretty much put together, apart from the harness parts here, and then I've just got to find somewhere for this to go. And initially I'm probably just going to stick it onto the top of there with some self-adhesive tape, and this orange plug plugs into the front of the MCM there, and that's basically it. So that's what it's probably going to roughly look like initially, and then underneath there will sit the pack, and the car, this bit won't care anything about the pack at all, because it gets all this information from the hacked modules here. All it needs is a battery, basically. It can be anything, 100 volts, 200 volts, 190 volts anyway. It could be anything from 100 volts to 190 volts, and we just plug that into the Anderson connector underneath, turn it on, and this bit should all work. So that's where we are at the moment, just to try and make it easier to test. Really, it saves having to make a load of stuff to fit all this in, and I know I've got the ducting, and I know I've got the cooling, etc., etc. So it's just a question now of chucking some batteries underneath. So initially for testing this, I don't actually need to use the super duper new Honda Accord batteries. I can just chuck in some of those LTO cells I had before, or almost anything. I could chuck in a 200 volt nickel metal hydride pack made out of sticks down there if I wanted to. So anything will do to test it, because all it needs is that double connector, and away we go.